Good afternoon. My name is Mark Stewart. I'm the Director of RSK Geosciences Business. I'd like to welcome you all to the third of our Down to Earth webinars, which today is on a subject close to my heart: economic design and procurement of ground investigations, a consultant's view. So first, I'd like to just run through some housekeeping with you. All your microphones are automatically muted through the webinar, so we can't hear you, but you can hear us. During the presentation, you can post questions, and there'll be a Q&A session at the end. And we'll answer as many questions as we can. If we can't, we'll get back to you individually with the answers. Shortly after the webinar, you'll receive a link to a short survey. So if you could take a few minutes to provide feedback when we've finished, so we can improve on future webinars, that'd be much appreciated. So with further ado, I'd like to introduce Jeremy Leach, who's going to be presenting to us this afternoon. Jeremy is an Associate Director and Team Leader for our South West and South Wales Geoscience teams. He's got 14 years experience in contaminated land consultancy, working for numerous residential development clients, contractors and government industry sectors. Jeremy has a wide range of experience across ground investigation design, data interpretation, human health, and control waters risk assessment. Jeremy's designed and executed consultancy-led ground investigations ranging in value from a few thousands up to several hundreds of thousands of pounds, covering large strategic land developments to industrial and urban contaminated sites. So over to Jeremy.
Thanks, Mark. Good afternoon, everyone. Let's make a start then. So, as Mark said, this afternoon's presentation is around the cost-effective procurement of ground investigation. And what I wanted to look at was the difference between cheap and cost-effective. Well, cheap and cost-effective, are they the same? No, I disagree. I think they're actually very different. So, cheap. What is cheap? Well, cheap could be unreliable. And it could be that cheap is not actually fit for the intended purpose. Cheap essentially is a comparison between similar products or services. And what you need to be asking yourself is, if something is cheap, well, why is it cheap? Why can a certain company or certain organization produce something cheaper or for less cost than the other? So cost effective then. Cost effective could be value for money. It's in the context of the quality of the service being provided, and it's more than just getting something of quality for a cheap price. Cost effective is also proportionate to the work involved or the product provided. So I'm going to show you a quick video now, which I think provides a big brand's take on the difference between cost and cheap and cost effective. Now, if you're watching this as a recorded session, the video won't play, but it's fairly easy to find off your own back. So, as long as it does the job. Now, I just want to point out at this point that all credit should go to the producers of the advert, of course, and RSK did not own it in any way, and its inclusion is no endorsement from RSK for the product featured. So, VW's viewpoint then is that cost and quality are closely linked. That's their sort of the thrust behind their branding. So there's hidden benefits behind that cost. It's not as simple as going, that is more expensive than something else. Hidden benefits in the context of a car, maybe it's safety, is it reliability, Is it customer service? Product development, what research has gone into producing that product? What experience have they used? How robustly has it been tested? These are all things that build in to why this may be cost effective as opposed to cheap. So let's use this now as an example, as a made-up example for a ground investigation. Let's pretend that the brief for the investigation is to provide information for pile design. Now, a cheap option could be simply to undertake hand excavated pits to prove the published geology. Is this suitable? No. Is this cost effective? No, probably not, when you start to factor in the need for additional investigations after this, or the sort of caveats and risk items that a contractor is going to place on this. But it is cheap. So let's look at a slightly more realistic scenario, because that is a bit extreme. So let's imagine we have a proposed residential development. Now the investigation is being procured on behalf of the vendor. And the vendor just has come out and provided a red line and would like an investigation. Often in this scenario, a range of scopes and associated costs are obtained because, as with most things, everyone has slightly different ideas about the best way forward to do this. And let's imagine in the scenario that it's a pure numbers comparison, that the cheapest investigation is commissioned and there's no consideration around anything else. So as we said at the top, why is this cheaper? Why is this investigation cheaper? Well, maybe there was less exploratory holes, maybe there was less testing, and maybe there was less interpretation. All of this is going to essentially lead to data gaps. In this context, these data gaps would lead to risk items attributed by the developer. They would review this, and where there are uncertainties, risk items would be applied. From the vendor's point of view, this would result in a reduction in the land value because these risk items would be taken off the value of the land. So was this cheap investigation cost effective? Again, probably not when you start to build in the risk items. So let's extend this then. Let's imagine this cheaper investigation also allowed for less gas monitoring visits due to the, in a bid to keep the cost low. Also in a bid to keep the cost low, the amount of time allowed to undertake the reporting and interpretation was reduced. So maybe the site wasn't conceptualized correctly. This could in turn lead to an adequate characterization of the gas risk, whether it's the interpretation of the data set, albeit reduced, or, as I said, the conceptualization. Experience of this tells us that this will often lead to conservative recommendations, that overly conservative mitigating measures will be placed on this development, possibly as gas protection that may not be needed. So this may lead us to a need for additional monitoring or additional interpretation, and essentially there's almost a reworking of what's already been done. Or if that isn't undertaken, this could lead to an unnecessary cost to the developer, i.e. gas protection that isn't needed ultimately is installed. Again, is this cost effective? No. So how do we therefore design cost-effective ground investigations? Well, let's start at the point that the tender comes in. It's important you know your client and what is their driving factors, what is their interpretation of cost-effective. Is it cost? Is it as simple as a numbers game? Is it quality? Will the client value the breadth of experience that someone like RSK Geoscience can offer? and our ability to provide reports under schemes such as NQMS. Is it around timescale? Does the client have external time pressures, such as a design or planning deadline, or do they need to make a decision on a land deal? Or is it innovation? Is the client particularly interested in technologies that can be offered by someone like RSK Geosciences? Is it our ground modelling? Is it our mobile data capture? And have you got any past experience with the client? Use your CRM systems and your project management systems to recall that information. How and where have you worked with that client before? Where, what have you won? And importantly as well, what didn't you win? What were the reasons for that? So next, let's look at the investigation. So it's important you understand the aims of what the client is trying to get out of their investigation they've asked you to price. It's important to communicate with the client, acknowledge that the tender has come in, good customer service practices like that. Discussing the initial queries that you may have with them. Review all of that provided information in good time. Don't wait until the day of the deadline to do it, because it doesn't leave you much time then to raise any queries and come back to them. If a scope of works is provided, what was the origin of that scope? Where has it come from? Has it been drafted by someone who has the appropriate experience of ground investigation and is therefore able to put a good sound scope together? It's important to raise clarifications and ask questions. It's far better to discuss these things with the client as opposed to just filling your tender with caveats and assumptions. And also, don't be afraid to ask for a time extension if it's warranted. Again, do this in good time. Don't wait until an hour before the deadline asking for an extension, because that's ordinarily not going to go down well. And most clients are reasonable and understand that actually a complex bid requires due care and time to produce it. So next, we've got to know our client, we understand what they want. So what about our site? How do we find out about what our site is and what we should be considering? Well, we can use publicly available information sources, such as there's groundshore.io. This contains waste, LiDAR, mining information, and essentially is a reincarnation of, for those of you who remember the Environment Agency What's in Your Backyard website, it uses a lot of the same data sets on that. Here in the Southwest, we have something called Know Your Place, which I believe is a lottery-funded scheme, but it, amongst other things, provides historical map sets for most of the counties across the Southwest. The map sets aren't going to be quite as extensive as those that you can get from your third-party suppliers such as Groundshore or EnviroCheck, but they're good enough to have a good idea of the site. Magic Map, again, great mapping resources, aquifer designations, environmental designations, and that sort of thing. The Coal Authority Interactive Viewer. Now, a lot of this information is actually now available through the groundshore.io site as well, but this is the source of it essentially, and provides great information, particularly if you're in a coal mining area, as parts of the Southwest are. And finally, the Geology of Britain Viewer, powered by BGS. There's different forms of this. There's the classical view, and then there's the geo-index and various forms of it. But essentially, this presents the published geology via an interactive map. So I thought I'd just give you a quick flavour of a couple of these. Again, no way an endorsement of any of these products. It's just an example, and this is no way intended to be a way of showing you how to use them. I'm sure the providers will show you how to use them if that's required. But this is groundshore.io, and what we have here is the historical and authorized landfill layer. Now, the layers are just turned on the map, they're interactive and they can be interrogated. You can click on the polygons to give you some information. So this is there's Southwest Bristol, the green tag there is the RSK Bristol office. And you can see the landlord I've selected there, the little I dot. It gives information on the permits. Now, it's important to remember that the information is only ever going to be as good as the record keeping at the time. So what we've got there is pretty standard in terms of the age and licensing numbers. So the Coal Authority Viewer, again, interactive map. The layers can be turned on and off. Again, RSK office shown there with a red arrow. And what we've got here is the black hatching is showing development of high risk areas, and recorded mine entries are shown by the red crosses. So again, you can very quickly see when you're designing your ground investigation what sort of things you need to be aware of and how you need to pitch your investigation. And finally, the geology of Britain Viewer. As I've said, this is the classic view. It's the one that I quite like. Again, layers on and off, whether you want to show superficial or solid geology or both, and you can click on the various points to interrogate the published geology. There in links there as well to further information such as a lexicon and other resources. So in terms of the formulation and design of cost-effective ground investigations, and let's start to bring it all together. So first thing is to remember your aims and drivers, as we've discussed earlier. Apply your existing experience and knowledge. So what do you know about the area? Have you undertaken works on sites that are nearby or just sometimes even the same site? With the locations that RSK and the national footprint RSK Geosciences have, we're well placed to provide this regional knowledge, and the local office will probably have that knowledge of your site. Have the ground conditions there yielded certain results? For example, have the holes tended to refuse at a shallow depth? Can more holes be undertaken per day? And what is the most appropriate methodology for the investigation based on your knowledge of the site and of the area? If a scope has been provided based on your knowledge, would an alternative drilling methodology or plant be better suited? Would a track machine be better over a traditional wheeled backhoe type excavator? What about the type of drilling flush? Would air be suitable over a water flush? But if considering all of this is not as simple as which is going to provide the quickest results, you need to bring in which is going to provide the highest quality. Are there other things to consider, such as cleanup costs? And as I've alluded to, don't be afraid to suggest and discuss with the client alternative scopes if you believe that based on your knowledge of the site that a different approach will gain better quality of information for them. So use of resources then when you're designing your ground investigation, consider the bigger picture and possibly where additional items can reduce the time or increase efficiency on site. For example, would the inclusion of additional labour resource or a labourer on site help the higher value assets to keep working? An example of this could be rotary drilling, as we've got here. Would an additional labour resource be able to maintain and refill the water bowsers, in addition to helping with moving the rig and the drilling setup between boreholes? So if we consider a rotary rig at, say, £1,400 for a day, if the crew was, every time they had to go and fill water, with that maybe taking an hour, that's £175 to fill a bowser, which I think a lot of people would say if I offered you £175 to spend an hour filling a bowser, you'd probably do it. And are the works such that can multiple items of plant be run at the same time and managed by one engineer? Is not always possible on some sites and some works, of course, but often it can be doable. As I said, heavily dependent on what you're actually doing. So what I've tried to put together to illustrate this is a bit of a resource hierarchy. So let's imagine we have a drilling rig at the top. Maybe we have a piece of plant like an excavator, a 360, something that's going to cost a fair bit amount a day next day. We have a site engineer. And then we have a labourer. So this is set up broadly that cost per day increases as we go up the pyramid. And therefore, what we want to maintain is that utilisation is higher as we go up the pyramid. So what we're looking here is at using the lower tiers to facilitate the upper tiers. Because it's all about keeping that expensive asset, drilling rig, turning as much as we can. So let's work through now a real world example as opposed to these sites that I made up previously. So this is another greenfield site which is proposed for residential development. There was an existing investigation undertaken by others, and this showed that there was essentially poor infiltration rates, perfectly adequate investigation, and in return poor results for the infiltration. The lack of, therefore, immediate infiltration-based drainage and the lack of an outfall meant that the sewer connection costs for the clients were extremely high, bordering on prohibitive. So when the request for further investigation came in to us, first thing we did was review the published geology and review sites that we've done in the local vicinity. Now, this showed that there was predominantly cohesive units present, but within the succession, there were sandstone units known to exist based on our experience. We also undertook a review of the topographical data via traditional ornament survey and also LiDAR data that's freely available. And what this showed was a break in slope. Now, break in slope in depth coupled with the published geology indicated that there was a potential for sandstone units to be present at shallow depth as we moved down topography. We therefore suggested that there was a day of trial pitting in addition to the 3 days of soakaway testing requested to essentially prove this presence of the sandstone and delineate that. This then allowed the further infiltration testing to be targeted at these sandstone units where they were present. The result of this was that there were viable infiltration results achieved, which allowed the drainage to be discharged to ground as part of the future development. So was this the cheapest option? No, it wasn't. It actually included an additional day on site over and above what was originally requested. However, was it cost effective? I think you'll agree. Yes, it was when you consider what the sewer costs would have been. So in summary then, I think we can bring this all together by saying, first off, know your client. Take the time to understand what are their pressures, what is driving them, and where are they trying to end up. Understand the aims of the investigation. What is it that they are trying to achieve out of it, and what are they trying to fulfill? Is it to maintain a land value? Is it to provide design data? Is it to discharge planning? Research and understand your site. Take the time to look at it and to be able to tailor your investigation. Don't be afraid to go back to the client and have that discussion around where you can make improvements for them or where you may be able to gain a better quality of data. and use the resources available to you efficiently and effectively. Look at the items as we discussed around. It may initially seem counterintuitive to include additional items, but that in turn can increase the efficiency of the more expensive. Finally, I just wanted to leave you with a quote. Now, depending on who you believe, it's either attributed to Benjamin Franklin or Aldo Gucci. It's the bitterness of poor quality remains long after the sweetness of low price is forgotten, which I think sums it up quite nicely in that a cheap investigation may seem good at the time, but ultimately may not fulfill what you need it to. So that brings my slides to an end. We welcome to answer any questions that you may have. If you can either provide them via the chat box, or please do email me with anything that you may have, or anything that you want to know if you don't want to put it. Yeah. Okay. Thank you very much,
Jeremy. Thank you, Jeremy. Very interesting and informative talk. Got a few questions that have come in for you.
Yeah. Okay.
Are you ready?
Yeah, fire away.
So, is a single investigation or phased investigation better value, I guess?
It really depends on the site, and that's not me trying to wriggle out and give a vague answer. If a phased investigation can often be more effective because each phase builds on the last and essentially refines what you're doing. However, a single investigation, if time is an issue, a single investigation is clearly going to be better from that sense. And a single investigation will save on things like mobilisation costs.
Okay. Does the method of drilling boreholes make that much difference time-wise?
Good one. Yes, it can do, but the most important thing is remembering that quality of data that you are trying to obtain and what you are trying to achieve, and the ground conditions that you're trying to achieve it from will ultimately dictate the drilling methodology and the flush. And for those of you who don't know what I'm talking about, flush, it's how the cuttings are lifted during the drilling process and how the drill bit is cooled. So that should dictate what you use. But yet time, if you do have options and depending on the ground conditions, then yes, different methodologies can speed things up.
Okay. So one about regulators. At what stage should you consult with various regulators? And I guess how would that impact on you on costs?
Yeah. Again, interesting. It really depends on what stage the investigation is and what you're trying to get out of it. If it's a particularly contentious site, if it's more often than not probably a brownfield site, and if there's previous history with it, again, if time allows, is always good to consult with that regulator, really to agree the scope of your investigation prior to breaking ground, to basically ensure that everyone's on the same page and you're all in agreement that what you are proposing is going to fulfill what is needed from the client's point of view, and ultimately to give the regulator satisfaction that they can then sign it off as appropriate.
And I guess not having that agreement could cost you more money in the long run, having to go back.
Well, yes, and yeah, that's it. Indeed, if there is a significant difference of opinion that can't be resolved, yeah, exactly, you could end up having to revisit and rework.
Okay. You froze there, Jeremy, I think, but I can hear you still.
Yeah. Okay.
Okay. Good. One leads on from that, I guess. What extra costs and resources would typically be needed for a heavily contaminated site?
It depends on how. If we're talking about a red setup, then there is going to be increased levels of welfare, possibly decontamination units, in addition to the PPE that will be required for the site staff. There's other elements to consider as well. For example, if you are on a red site, a contaminated site, do you need to use different laboratories? If there's going to be geotechnical testing from the contaminated material, do you need to make allowances for getting that to a different lab, a red lab set up? Do you need to store the materials, the samples differently on site? You need to make sure they're segregated. So yeah, there's can be quite a lot of additional resource and plant needed for a red, you know, a decent contaminated site over and above a greenfield.
Okay, lovely. Just one point that's come in about the ground short IO is there's some doubt as to whether it extends to Scotland. So whether there are other resources available around the country.
I believe, yes, I believe SEPA do run a version of it, and I believe, yeah, with aquifer designation, and I think there's groundwater units from SEPA, and now I'm also thinking as well in terms of NRW, whether that is covered on ground short as well. There's certainly something, yeah, by all means, whoever raised that point, by all means, if you want to email me, I'll gladly look into that and come back to you.
Yeah, and similarly in Northern Ireland, I guess that's probably the same answer. We'll come back to you on that. Yes,
yeah,
we'll come back
yeah,
to you.
If you want to email, please do. I can come back to you.
Yeah, lovely. Well, I think we're about finished. So thank you very much, Jeremy.
Thank you.
I'd like to just thank Jeremy for a really good talk and answering all those questions. Actually, one's just come in. Actually,
I got it. Yeah.
As it's from Tom, we'll say, can you say anything more about the relationship between SI costs and remediation costs?
Yeah, absolutely. I suppose you're going to end up paying for your site at some point. And again, it's probably similar to what I was saying about the maintaining the land value, and that a more robust ground investigation will ultimately give a better level of confidence when it comes to your planning of your remediation, and will allow a better cost to be placed upon that. Now, you may even, whether you even need to go as far as remediation, whether a robust investigation and the interpretation behind it, and a decent detailed quantitative risk assessment and DQRA may actually minimise or remove your need for remediation. But again, that comes off of a good robust GI to generate that understanding.
Okay, great. Thanks so much, Jeremy. Well, I'd just like to wrap it up there. So thank everybody for attending.
Thank you.
The feedback questionnaire will be with you in about an hour. Our next topic for discussion in a month's time on our Down to Earth series is big waste and material reuse on site. So about the clear code of practice and other methods for reusing materials arising on sites. That's on Tuesday, 10th of August with Ben Winch. So thanks very much, and thanks for joining.
Cheers all. Thank you very much.
Bye-bye.